Hey, hi, welcome back to my channel. I know it's been a while since I have posted any video. Actually, I have moved between cities, and that's what kept me busy for the past few months that I couldn't record any video. But here I'm back with some amazing and interesting content this time. I'm planning to start a DSA series. We'll be solving various interesting DSA problems together. We'll be breaking down the problem into steps. We'll be discussing about various approaches to solve a problem. So if you have any approach, any better approach in your mind, then whatever is being presented in this video, you can feel free to drop it in the comment section, and it's more than appreciated. And if you are preparing for any coding interviews or just brushing up your coding skills, then you are in the right place. Just make sure to stick around, drop your comments in the comment section, and let's level up our DSA game together. So let's get started. All right. So this is the sheet that we are going to follow for solving various DSA questions. Contains an exhaustive set of all the topics that has been asked and questions that has been asked in companies like Google, Amazon, Microsoft, Facebook, Swiggy, and Flipkart. So there are all total of 191 problems, and we'll be solving all of them. So let's start with the very first problem for today, that is the set matrix 0. Okay, so it's 73rd number Leetcode problem and is of medium difficulty. The question states that given an m cross an integer matrix, if an element is 0, set its entire row and columns to 0, and you must do it in place. By in place, it means that we are not supposed to use any extra amount of memory space for computing our result. So the example 1, let's see what has happened in this example 1. This is our input and this is our output. So for this 0, we have this entire row converted into 0. And for this 0, we have this entire column converted into 0. Similarly, for here in this example, we have for this 0, we have this entire row converted into 0, and this entire column has been converted into 0. Again, for this 0, this entire row is already 0, and this entire column has been converted into 0. Now let's look into the constraints. M is matrix dot length. So this is a 2D matrix, right? So matrix dot length returns the number of rows in the matrix, and matrix of 0 dot length returns the number of columns in the matrix. As matrix of 0 is this one, so the number of columns in this matrix is 4, so n is 4, and the number of rows and the number of columns lies between 1 and 200, and the matrix cell values lies between minus 2 to the power of 31 to plus 2 to the power of 31 minus 1, which is well within the signed integer range. There are some follow-up statements. The straightforward approach using m cross n space is probably a bad idea. So it states that using any extra space for computing the result is a bad idea. Like m cross n space, usage of m cross n space is probably a bad idea. So we can start off with m cross n, then we can optimize it to m plus n, and after that we can have a constant space solution. So we'll be discussing about all the approaches, m cross n, m plus n, and constant space solution. So let me share my iPad screen. It's okay. So let's look into the first example. So first example is something like this. It's 1, 2, 3, 4, 0, 5, 6, 7, and 8. It's something like this. So the and a resultant arrays, a resultant matrix is supposed to be like this, right? So how to arrive into this result? The very first solution that strikes in our mind is we'll be iterating through this entire matrix. Right. On encountering a 0, I convert this entire column to 0 and this entire row to 0 using two loops. But will this solution really work? Let's see. Now let's look into the next example. We have 0, 1, 1, 0, 2, 3, 3, 2, 4, 5, 5, and 4. So do you think it will work here? Let's check it out. We encounter a 0, convert the entire convert the entire row to 0, convert the entire column to 0. Then we encounter this 0. Like we have already changed the input matrix, we encounter this 0. This entire column is changed to 0 and this entire row is changed to 0. For this 0, this entire column is changed to 0. For this 0, this entire column is changed to 0. But our expected result is this one, right? But we are getting, this is the expected result, but we are getting this result, which is not the desired result. So this solution won't work. Now the next thing which strikes our mind is maybe we can maintain a copy of the input matrix. Okay, so let's see. We have a 0, 1, 1, 0. We have 2, 2, 3, 3, 4, 5, 4, 4. Somewhat like this. This is, say for instance, this is our input matrix, and we are maintaining a copy of this input matrix. This is our input, and this is our copy. This is the copy matrix. So what we can think of doing is, we will be traversing through the input matrix, right? On encountering a 0, we will convert this copy matrix, all the rows present in the copy matrix, to 0, and all the columns in this copy matrix to 0. So this is the result after the first operation or first computation. Then we encounter a 1. There won't be any change. 1, again there is no change. So now we encounter a 0. So for this 0, this entire row is already 0. We need to change this entire column to 0, right? So for other, now we are traversing through the other elements, we encounter a 2, 2, 3, 4, 5. So there won't be any change since all other elements are non-zero. So this is similar to the desired result, right? So our desired output is now similar. So this can be a probable solution. But you know what's the problem with this solution? We are using a space of order of m cross n. So we are using extra amount of space with the order of m cross n. So this is our space complexity. Now what about the time complexity? So we are iterating through the entire array, right? So we are going to visit each and every element present in the matrix. So that will result in an order of m cross n. On encountering a 0, we will be changing m rows, m columns to 0 and n rows to 0. So it will be somewhat like m plus n. Now if we consider it as a square matrix of side n, so the time complexity will result into something like order of n cube, which is again very high. Now we can think of optimizations, right? So we cannot, the interviewer won't be happy with this solution. So let's think of what optimization we can do. So let's first think about the space optimization. Instead of using an m cross n matrix, let's use two different arrays. This is our column array, and we have our row array. And this is our original input. So we will be declaring the column matrix, column array and the row array using primitive types m or n, right? So initially all these elements are 0, initialized as 0. So this is the default behavior of primitive type arrays in Java. All the elements are initialized as 0. So the solution approach which we can think of doing is, we'll be iterating through the matrix, element by element, row by row, on encountering a 0. So I encounter a 0. So the 0th row and the 0th column has a 0 value. I change this column matrix to 0. 0th index of the column matrix is changed to 0, and 0th row of the row array is changed to 0. Then I encounter a 1, no change to the column and row arrays. Again a 1, no change to the column and row arrays. Again I encounter a 0. I change this column to 0. I change this 0 to 1, right? No change, no change, no change, no change. No change for this one, no change for this one, and no change for this one. Now, using this column array and row array, we can arrive to our result. How? Let's see. Now, this is our original matrix. We'll be iterating through the matrix once again, encountering a 0. So we won't be looking into the nature of the cell or whatever the value which is present in the cell. So now we are at column 0 and row 0. Let's check the column array at index 0 and row array at index 0. It's 1, and it's 1 here. So if column equals to 1 or row equals to 1, we'll be setting the element value as 0. So it's already 0. So no need to change. So here in this case, the row value is 1 and the column is 0. We change it to 0. Row value is 1, column is 0. We change it to 0. Row value is 1 as well as the column value is also 1. So it's already 0 and it needs to be changed to 0. Again, next, this element, it has a column value of 1, so I change it to 0. So here this column value is 0, and this is again 0, so no change. 0 and 0, no change. 1, here we encounter a 1 in this case, so I change it to a 0. Again I encounter a 1 in this case, I change it to a 0. I encounter a 5, but here it's a 0 and here it's a 0, no, so no change. Again this 5, here it's a 0 and here it's a 0, so no change. I encounter a 1, so I change it to 0. Now the result is like this. Now let's analyze the time and space complexities. So the time complexity in this case, what do you think is the time complexity? We are iterating through the array 2 times. So, sorry, it's the matrix. So we are iterating through the matrix 2 times, and the matrix contains m cross n elements. Now let's assume that the matrix is a square matrix. So it will have, say for instance, n elements as n as the number of rows and n as the number of columns. So traversing through the matrix will result in n into n operations, that is n square operations. So for the first traversal, while like setting the flags in column and row arrays, there will be n square traversals, and while setting the result, there will be another n square traversals or n square visits to each and every cell. So it will add up to order of 2 to the power of n square, 2 to n square, right? So we can remove this 2. So it's order of n square. So we have successfully reduced the time complexity to an order of n square. This is our time complexity. What about the space? We are using an extra amount of space. We are using a row array and we are using a column array, right? So row array will be of, say for instance, size n. Column array is of size n. Maybe I have the flip version. Okay. This is the column array and this is the row array. So we are using an extra m plus n space. So we have reduced the space complexity too from order of m into n to order of m plus n. Now let's further reduce the space complexity. Say for instance, we have the matrix like this: 0, 1, 1, 1, 0, 2, 2, 3, 3, 4, 5, 5, 4. So the idea is we are going to use this row and this column as the 0 indicators in the matrix. So we are not going to use any extra space for this time. So since we are using these two, like utilizing these two rows for the 0 indicators, what we can do is we can have referred like use two different variables, one as the row variable and the other one will be a column. So if there is any 0 in this row will be initialized to true, and if there is any 0 in this column will be initialized to true. So what we will do, we will be like iterating through the entire matrix. So since I encounter a 0 here, so this row value is changed to true. Now I encounter a 1, no change, 1, no change, again 0, this row is again changed to true. So for 2 there is no change. So I encounter a 2 now, no change. I encounter a 0 now. I change this to 0 and I change this to 0, right? I encounter a 3, no change, no change. 4, no change. 5, no change. 4, no change. 4, no change. So one set of iteration is complete. Now we'll be iterating through this matrix once again. So we'll be starting from 1, 1 this time. We'll start to iterate from 1, 1 this time. So for row 1 and column 1, let's see if there is any 1. So for column 1, the value of column 1 is 1. So no change, but the value of row 1 is 0. So I change this to 0. So for this 0, okay, we are not looking into the cell values this time. We are just iterating and looking into the column and row values. So here the column and row values both are 0. So this is 0 and it's like if there had been a non-zero, it will be changed to a 0. Now we encounter a 3, but here it's a 0. So I change it to a 0. We again encounter a 3. Now we have a 0 here and a 0 here. It's again changed to a 0. We encounter a 4 this time, but it's a 1 here and a 4 here. So no change for this one. So for this 5, we have a 0 here and a 4 here. So it's again changed to a 0. We have a 1 here and a 4 here. It's 4 and it will remain as a 4. We have a 0 here and a 4 here. So we change it to a 0. Now, the final thing, row is true, right? So I'll convert this entire row to 0. We have this 5. Yeah. Column is true. I convert this entire column to 0. And we have the converted elements as 0, 4, 0, 0, 0, 4, 0, 0. This is our desired result. So what do you think is the time complexity now? We are iterating through the entire matrix 2 times. Had this been a square matrix of side n, it would be an order of 2n square or an order of n square. This is quite good as a solution. This is our time complexity. What about the space complexity this time? We are not using any extra copy matrix. We are not using any array to maintain the flags that whether there is a 0 inside of the matrix row or column or not. So there is no extra space being used this time. We can happily say that this time the space complexity is constant order of 1. Right. So let's code this solution. Let's jump onto the code editor this time. All right, so let's look into the code. I have stored the number of rows and columns in two different integer variables. I have also maintained two different Boolean flags, row flag and column flag. Now I'm iterating through this entire matrix, starting from 0, 0 till m, n or n, whatever convention you follow. So if I encounter any 0, that is the cell value is 0, matrix of row, column is 0. What we do is we change this row, 0 and column, 0 to 0. So here we find a 0. So in this case, this will be changed to 0 and this will be changed to 0. It will be used in computing the result of the inner matrix starting from 1, 1 in the later section of this code here. So this row and this column is updated as per the contents of this inner matrix in this loop. And now, for instance, we get something like this. If the row is 0, then which one we should be updating, right? So in case the row is 0, that is this one, then this column flag is set to true. That means matrix of row, column is 0 and the row is also 0. That means this row contains one 0. So to indicate that, I'm updating the column flag to true. So this column flag is used later to convert all the cells in this column or in this row to 0. And in other case, if the column is 0, if it is this one, if the column is 0 and there is a 0 in the column and it's found true, so we update the row flag variable to true in this case. And this row flag, if the row flag is true, I'll iterate through this column and convert each and every cell in this column to 0. So this is how the code looks like. Now let's run and test. Initial test cases have passed and let's submit and see. Okay, it takes 1 millisecond and it's better than 75.44%. And this is the memory usage. So this is about the set matrix 0 problem. If you have any confusion or if you have any better solution suggestion, you can definitely drop your solution into the comment. So thank you.